Mm, 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 mm. All right. Is this not HD? It should be HD. Profile YouTube. Yeah, this should be HD. Oh, there. Okay, it's good. It's good. We're good. So I actually made a topics list this time, so hopefully we will be less scatterbrained. So first, I'm going to make some assumptions. I'm going to assume that you are on Windows, and I'm going to assume that you are watching this with the purpose of getting into Unity. So what we are going to start doing is getting Visual Studio. To do that, we just need to Google something like Visual Studio Installer. Just take the first link. We go here, we download, and that should give you the Visual Studio Installer, which I already have. It looks like this. Then from here, when you go through it, it should ask you about workloads. I'm just going to go into my installation here and show you what I have. So I have the .NET Desktop, the desktop development with C++ because I do a bit of that as well. Um, though I think you can get away with just having the .NET Desktop development and the game development with Unity workloads. And later on, we're going to also be looking at Git. Um, so you can get that through here as well. You can get Git for Windows if you go to the individual components. I have it installed separately, and you can also get the GitHub extension for Visual Studio. You install that, hit launch, and that should have taken us through getting it. And now let's make a solution. So we're just going to start out with some basic C sharp, no Unity. That would just complicate things. So let's just start out with that. So we want to create a new project, and we want it to be C sharp. We'll make what's called a console app, and we'll hit next. We'll call it something like teaching C sharp. And then for the location, I recommend you have a folder somewhere. I just have one here on my D drive called source, where I have all my projects. And I have my kind of trash folder here, and then I'll select that. I already think that I have some teaching C sharp here, so I'm just gonna go ahead and delete that. And let's go back one folder. And we'll just pick this folder. There we go. And then it asks for something called the solution name. So when you make a project with Visual Studio, the way that Visual Studio keeps track of the files in your project is via something called a solution. So the solution is just a top level file. I can try and draw it. So we'll go into Paint real quick and you'll get my touchpad painting. So we have the solution at the top, and then under the solution we have projects. Oh, that's an S. There we go. I really need to get a pen. Wait, that's not how you spell project. There we go. Project. And then the project then keeps track of the files inside of it. So what we named here was the project that we're creating. And then what we name here is the solution. So that's the top level thing. And then we can place the solution and the project in the same directory. Directory is just another word for folder. We don't want to do that. We want a folder for our project and then the solution at the top level. And I'll show you why in a second. There we go. So this is the template for a console app. Let me just go ahead and create another project under this solution. So right now I'm in the Solution Explorer, where is, I can see my projects and solutions there. Going to right click, add, new project. And then we're going to do a class library, .NET Standard. Click next. And we can just call this something like teaching C#. .lib. .lib. There we go. And now if I go to the directory, you can see that I have my solution file at the root, and then each project gets its own folder, which arguably is a nice way to structure things. And inside of Visual Studio, that's also how it's logically structured. So each project has its own files and dependencies under it, and then they're all connected by the solution. If you accidentally click this button, switch views, that just switches you between what it looks like on the computer in the file system, and then what it looks like as the solution. There's nothing magical about the solution and the project files. If I go to the solution file, for instance, and I open it in something like Notepad, I have Notepad++, you'll see that it's just text. And it shows the formatting version. It's a Visual Studio solution file. The version of Visual Studio, and then it has some projects here, and then it has this long string of characters, which is something that identifies that project we made. And you can see it has one for each of them and where they are. So if you change where it is in the file system, it needs to be changed in here as well. And then it just talks a bit about how to build the project. So, take the code and turn it into something the machine understands. And the different build configurations we have. And any solution nodes that should be hidden, and so on and so on. And if we go and look at the project, which is a CS Proj, Proj, and try and open that in a text editing software, we'll see that much like the other one, it's just text. So it says which SDK, so that's development kit we're using, and that's .NET. That makes sense. We are making an exe because we can run this thing once we've built it. It's a console app. And the framework we're on is .NET Core 3.1. Doesn't really matter for this tutorial which framework you're on. So nothing magical there. Now let's go back to our console app, go into the program, and let's talk a bit about what an entry point is. So an entry point is where the computer is told to start in the program when it is run. So anything that needs to run on a computer needs to tell it where to start. For C Sharp, in a console app, the entry point is inside a program in our void main. And there are different ways to write this void main depending on which kind of console application you're writing. So if you want to look into that, you can always look it up. So let's try and look up C# entry point, probably console app. Well, we get a tutorial down here. That's not really what I wanted. Let's try and Google a bit better. So just C# entry point, will that do us? Ah, here we go, specifying an entry point. Not quite there yet. I think that's if you want to create your own entry point. Maybe third time the charm. C#. And I think an important skill, especially in something like programming, is to be able to Google a bit around. Was this not what we just looked at? But that's for unmanaged DLLs. What if I just do entry point? What do we then get? That's it? I could have sworn. So this is for C++. That's not what I want. C#. Entry point. All right, let's try and search for void main instead. Oh, there we go. Main and command line arguments. Yeah, so another skill, this isn't really on my docket, but it's something that I'm going to be talking about throughout this series, is that I don't want to go in super prepared, because then you won't get to see what it's like to actually code. And another thing about this series is that this is not going to be best practices. This is going to get you started with some C# principles and some programming concepts. And then I'll be making an intermediate series where we will start looking at best practices and source control and all that good jam. And then we'll move into Unity. So yeah, really learn to Google, learn to search, use resources. So this resource that I'm looking at, this is the Microsoft documentation. Highly recommended. And it goes through down here an overview of an entry point, what you need for what, and the different ways it can look. Important to look at and get comfortable and familiar with. Now, it has already put in something here for us, console.writeLine. And the console, if you don't already know, I'm just going to go here from teaching C# into the bin folder, which stands for binaries, into debug, and into Netcore app. So debug is our build name, and then Netcore app is the framework. Then I'm going to hold down Shift and right click, and then I'm going to open PowerShell. So PowerShell is an example of a console. You've probably also, if I do the Windows key R, and then I do CMD, we get the command prompt. You probably also know this. This is also a console. And console.writeLine, if I just do Control Shift B, as in Bob, we will build the solution, turning all of this code into something the machine can read. That has now put an exe in this folder I'm in. So I'm going to do a dot and a slash, and then I'm going to press tab until I'm on the exe, and then press enter, and that will run it. And you can see console.writeLine wrote this line in the console. Very self-explanatory. Hello world. And I think that should have taken us through the basics of it. And another thing you'll notice is that the program closed down afterwards. So you can see it runs, prints that out, and then it closes. And the reason it does that is because there is nothing after WriteLine, so it just closes. Let's go back to my topic list. That is the application entry point. That is building and running. So that is taking us through the basic setup. So we're now ready to look at some types. So the first type, well, first of all, what is a type? It's a good thing I made a list. So first of all, what is a type? So if we look at how a computer works, you probably know this, it has a lot of ones and zeros. So let me just do a new one. And if we imagine we have a block of memory here, and there can be all sorts of, that's not what I wanted, block of memory, and there can be all sorts of ones and zeros inside of here. Give me a brush. So we could have 0, 1 inside of here, for instance. And if you know a little about binary, you would know that this is 2. This is the number 2. But that only makes sense if the computer knows to read this as the number 2. Imagine that this was a piece of text. What would 0, 1 be then? Computers usually use some kind of character set. Most of them use ASCII. So we can look at ASCII, for instance, and get an ASCII table somewhere, like here, from Wikipedia. And hopefully it has just a table somewhere. There we go. So we can see here for us, the 0000010 would have been a start of text. So if we wanted to do, let's see, if we wanted to do, where is the character? Let's do 0, right? So if we wanted to do 0, we would need 0, 1, 1, and then zeros in our piece of memory, and then tell the computer to read that as text, and it would print out 0. Right? So that's why we have types, because we need to tell the computer how to understand the binary that we are giving it. That's just a very fundamental way of looking at it without too much fuss. So why do we use types other than to tell the computer how to read it? We use types to also help ourselves as programmers. The compiler, the thing that takes your code and turns it into something the machine can run, is able to help you out a lot when you code, when it knows the types that your data has. So let's take this for instance again. So let's say that this block of memory, we told the computer that this was a number. And then we make another block of memory, right? Something like this. And let me just get rid of that real quick. This never existed. There we are. Get my brush back, and then let's put in just 1. 1 is fine. So this is a number. I'm just going to do an N for number. And then this is a T for text. So we want the computer to read this is text and this is a number. Now, what would happen if we tried adding these two? So we take 10 plus 1 in binary. So what should that give us? Should it be 11 in binary as a number? That would be 3. Should it be the number 2 followed by whichever character this would be? It's very ambiguous. That means there's no clear answer. So what the computer will do here for us, if there's no easily accepted answer to converting between these types, is that it will give us an error, and it will tell us that these types, don't get along. The specific error that we get is probably going to look something like this. So let's try and say we have a string. So that's a piece of text. If I hover over a string here, I can see it says it represents text as a sequence of UTF-16 code units. So we could Google UTF-16, and find a table somewhere. Do we not? We don't have a table here. Okay. Table. There we go. Something like this, right? So here we would then see this is then the byte in hexadecimal. So that's just, you have binary, you have hexadecimal, you have decimal. It's just counting systems. Don't get super confused by it. This is a number, all right? I know it has text, but it's a number. And then if we go through here, you can see all the numbers we need for the different characters. So in UTF-16, A would be the number, whatever this is, in hexadecimal. I'm not very good at reading hexadecimal. Right, so I'm just going to call it my string. And then the way you do a string is that you have these are not called apostrophes. I actually forget what they're called in English. Let me just very quickly for you figure out what this character is called. Quotation mark. There we go. Thank you. And let's just have A. A is fine. Well, actually, let's do a big A. There we go. And then let's have an int. So an int is just a whole number for now. That's fine. And I'll call it my int. And we'll have something like 1 inside of it. And then let's say my int is then equals to whatever was inside of my int plus whatever is inside of my string. And we can see here the error we get is cannot implicitly convert type string to int. So that's what I was talking about. So it's telling us, if I go back here, it's telling us, I don't know how to make text into a number without you telling me how. Because, it might be that we had the number 1 as a piece of text, and we actually wanted the number 1 and not whatever the byte for, the text 1 was. The compiler doesn't know that, so we need to tell it. So we could do that. We could say, let's say that we had the number 1 in here. So we could say, make that an int. So we have int dot parse. So that just means to read. So we want to parse this string. And this will then give us whatever the actual character is. Not the bytes for it, but the actual character. So this would give us 2. And let's try and prove that to ourselves by printing it out. There we go. I'm going to Control-Shift-B. We go to our console. Then I'm going to click the up arrow to go to whichever it was I last ran in the console and click Enter, and we get 2. So it didn't give us whatever the byte was for the text character 1. It gave us what the actual text character was as a number. So it's important to know stuff like that when you convert between types, because for the computer, it's just all binary memory. All right. Now I believe we start moving on to actual types. So that is our type safety. Then we have variables. We already kind of looked at it, but let's actually go through exactly what a variable is. So let's start out by seeing what the documentation says. As always, a good place to start when learning something is with the documentation for whatever language you're learning. So a variable represents a storage location, and that very much agrees with what we previously were talking about how a computer actually functions. And that's another thing you will notice, that the more you know about the concepts of programming and hardware, the more the language will make sense, because a language just implements the theory that you already know. Right. So let's see here. So each variable has a type and a value. So here they give an example of it. And then they go into some more specifics. And then they go into values and references, and outputs and local variables, and some default values. I think they basically go through everything here. Block statements, if statements, switch statements, there we go. So let's try and look a bit. So let's try and look at variables a bit more simplified. So the way that we do a variable is that I'm going to do a comment now. So that is //. So the compiler will just ignore this line now. So we won't get any errors. The way that we do it is that we have our type, then we have our symbol or identifier. I believe the C# compiler calls it an identifier. And then it's optional. I'm going to write optional like this, to then have an equals and then some value. And then you have to end the line with a semicolon. A semicolon is the end of a what's called a statement or declaration. So let's try that. So let's say that we want to make a number. Let's start with numbers. So we could go to the documentation. We could look at the language reference. We could go to types. And then you have this concept of value types and reference types. You don't know this right now, but a number is a value type. So you would probably see it if you expanded both of them, that none of this looks like a number. But if we click on the overview here, we will see somewhere down here that we have some built-in value types. So that is what the language comes with already for us. We have integrals, which are whole numbers. We have floating point, which are fractions. Then we have something called a bool, and a char. Let's start by looking at integrals. So remember how I said that the type tells you how the computer should read it? It also tells the computer how much room it should make for that type. So not all numbers are born equal. You'll see that byte, for instance, has a range of 0 to 255. And you can see here under size that it is an 8-bit integer. So that means there are 8 bits to a byte. If we look at something like a short, you'll see that it is twice the size, and therefore it makes sense that it would have twice the range in terms of binary. Obviously, this isn't twice as much as 255, but hopefully you know what I mean. The way that you would write it would be, I believe it's 2 to the power of whatever you have, so it would be 2 to the power of 16, and that would give you your range. If we do an int, which is the one I showed, you'll see that it's 32 bits, so again, twice as large. And you'll also see that some of them have negative and some of them only go down to 0. And you'll notice that it's signed and unsigned. That's because you use a bit to tell it whether or not there's a minus in front of the number, whether or not it's negative. And that's also why you'll notice that it's not an equal amount on, both sides. It's not like it's 0 and then the same amount on each side. It then shows us how to do a number. So int here is what's called a keyword. There is a list of keywords, I believe, down here, where you can read about them all. But what it's basically a keyword for is it's sort of like a shortcut for writing system.int32. So these two, int, myint a, I'm just going to call it, and system.int32, myint b, are the same. I can put 5 in here, and actually let me do something else to prove that they're the same. So we have these, and then I'm going to do something called a type comparison. So I'm going to say that my int a is my b. That's not what I wanted. System.int32. There we go. That should work, right? That's a type. Why does that not work? Right. There we go. The given expression is always of the provided int type. Yeah. So even the compiler is telling me this is dumb because, of course, the type that it is always going to be the type. S is just something you can do to check the type of whatever variable you have. Right. Great. It's great that the compiler is helping us. We should be happy about that. You'll also notice that it kind of grayed out system here because the name can be simplified. If I click on this and then I do control dot, reconnection successful. Are we back? All right, we are back. So you'll see here that it then shows us that it's going to change this line into this line because it prefers using the keyword over the actual system type. That makes sense. You'll notice that for all of the types we were just looking at, that they have some sort of keyword. It even says here that is then some .NET type right here. So that's good to know. Then it tells us the different ways that we can write our integer literals. We can write it as a decimal without any prefix. So that would just be this, for instance, like the number 5. So this is in a normal 10 counting number system. Then we have in hexadecimal. So that is starting with 0x. So we could try doing that. So we could do 0x f. I believe that is that not 15 or 16? I believe. You'll print them out afterwards, don't worry. Then we can do binary with 0b or 0 and then a big B, whatever. So let's try that. If I click on the right thing. So let's do int my int c and then do 0b and then let's do the number 2, right? So 1 0. That would be 2 in binary. So let's write these out. So let's do console.writeLine and then the first one. And you'll notice that we don't get an error here, even though it wants text written out in the console, because this, what's called a function, or method in this case, but it's a function. Let's just call it a function for now. Is able to take in a number and turn it into text for us. So that's very nice. I'm just going to hit Control C, Control V, change this to B, Control C, Control V, change this to a C. And then we are going to Control Shift B, and it saves our project whenever you build. So I didn't need to save it. You can see that on the color of these lines out here, what the state of all of the lines are. So let's go to our console, click the up arrow and run it. And we get 5, 15. So I was right, it's 15, and then 2. And that makes sense for us because that is what we put in. If we did something like 1 0, I believe this would be 16. So let's build that real quick. There we go, 16. Hexadecimal will be like that. Let's go down a little more. So now it's talking about how that you can suffix. So what we were doing before was prefixing. That means putting in front of. And then suffix is putting after. So now it's talking about how that we can suffix to make sure that the number we write is treated a certain way. So for instance, we could do the suffix L here, and that would make this a long, which is a, if I get to, there we go, which is a 64-bit number, which is too big to fit in our 32-bit number. And that's why we are getting an error here. It cannot implicitly convert. If we look at what else we have, we could also make them unsigned. So let's do that. A U here. And if we actually make this a long, you would see that it fits. Because this would be then a uint, if I turn it back here, we get the error. Because uint, you aren't guaranteed that you can reach the higher, uh, the upper range. Like if we go back and look, we can see here int, top range is 2 something. Here it's 4. So you aren't guaranteed that it fits, and that's why we get the error. If I made it something like a long, which even though it is unsigned, you can see that it fits, right? Our upper limit is well beyond the 4 whatever we got here. And what this should show you is that we can, you probably saw the name pop up a few times. I'll make the arrow again so we can see it. Implicit conversion. So a smaller type that is read the same way can always be implicitly converted to a larger type, right? So you can take the water in the small bucket, and no matter if it's full or not, you can pour it into a bigger bucket that also holds water. That makes sense. But you aren't guaranteed that the water you have in the bigger bucket can be poured into the smaller bucket without spilling. And let's try and see what happens if we start spilling in a bucket, to use some metaphors there. So we'll do a bite. We'll call it my bite. And I'll set it to 255, which is the upper limit. Then I'll say my bite will be equal to the value in my bite, so that would be 255 plus 1. And I just need to make sure this all becomes a byte. Will that do you? That will not do you. All right, we have to do it this way. That's fine. So, byte, and then another parentheses. So when I put the parentheses around this statement here, the value that it outputs is basically what is going to be put in here instead. I don't know if that makes sense. Hopefully it does. And then I want that value to then be treated as a byte. So this is me explicitly casting the result of this operation to a byte, instead of implicitly where we didn't have to do anything. You can also see me do it here. I could say I explicitly want this to be an int, and then put into a byte. Anyway, let's try and print this out. So console.writeLine my byte. Let's build it. Click the up arrow, enter, and we get 0. So you can probably see that we've rolled over onto the other end of our range. All right, so we went from 255 to 0. The way that you can think of this is that what the computer does underneath is that it says, okay, I need to add a bit to this. So now there's a bit here. And then I need to add another bit to this. So that means make this 0, make this 0. Oh, here's, the next place where I don't have a bit set. Let's set that. So then that would be, 0, 0, 1. And you basically keep doing that until that there's no more room, right? So it has 1 in all of them, and we say add 1. All right, so I should set this one to 0, this one to 0, and it keeps going through the entire number until everything is set to 0, and then it goes, well, I'm done, right? So that's how we do in this situation what's called overflowing. Now, let's imagine that you didn't want to overflow. Let's say that that was an error for your program. So how do you protect against that? I don't know if they actually show here. They probably do somewhere. Let me just double check. I don't see the keyword. All right. So the way that we would do it, I'm going to go into keywords, overview, and then we are going to do checked. And what this will give us is that we can make what's called a block. So whatever is inside of these curly braces is what we will refer to as a block. And that block will be checked for over and underflow. So, of course, this could also go the other way. Like if we said -1, if we were 0, -1, we would go to 255. But let's just try. So, checked. Then I press Control X as in xylophone, Control V as in Vicky, Control Shift B, and we try running the program again. And now we get an unhandled exception, system overflow exception. Arithmetic operation resulted in an overflow, which is what we were expecting, so that's good. We can also look at this error and learn a bit about debugging. So it happened at main, and it's in the file program.cs. So it's this program file in this method at line 13 right here. And that makes sense because that is where the error occurs. We'll look more into debugging later. Right now, we should just focus on types. So that should cover the integrals. Of course, we will look into it in a more and more advanced manner as we move forward. But right now, I just want you to, just see what the language has and get exposed to some of the basic programming concepts. So the next built-in value type we're going to look at is floating point. We have float, double, and decimal. And again, you can see that they are different in their size. And for floating point, they are also different in their precision. So how precise a fraction they will go down to. So let's have a look at that real quick. Now, the thing about floating point numbers is that they are an approximation. We basically trade off a bit of accuracy for much faster processing in computers when it comes to floating point. If you're very interested in how floating point works, I believe that there is a all you need to know about floating point. All you need to know about Brexit. There we go. Floating point. Floating dash point dash GUI.de. There you go. And the thing that they're showing here about 0.1 plus 0.2 becoming 0.3, a bunch of zeros, and then 4 just goes to show that you should be careful when comparing floating point numbers. I believe that C# is fairly good at handling floating point numbers. So if we do a float and we call this one, 0, 1, So the error we get here is that normally when we don't do a suffix, it is a double, and the double is larger than the float. And that's why if we want a float, we need to put an F. And then we will do a float 02 F. And then we will say float. So there should be 03. And we will do 01 plus 02. And then we will print it out. So let's see what kinds of imprecisions we get here, if any. Right. So we didn't get any imprecision, it appears. I can try in my browser with JavaScript. That is what runs in your browser. I'm going to right-click, view page source. That is not what I want. Inspect is what I want. There we go. And then I have this console down here. If you don't have it right now, you can press escape to get it up. Then I will do 0.1 plus 0.2. And indeed here we get some kind of imprecision. You'll also maybe notice that at very, very large numbers, smaller numbers are ignored. An example I can set up that shows that is so let's do a float, my float, and some of this I want you to ignore, but we'll see. And then we'll just have an int, my int equals 0. And then we will do while my float is equal to my int. So while these are, the same number. If you don't understand this yet, loops and statements and all of that in comparison, we will get to it. I just want to show how floats can start ignoring small values at very large numbers. Then we will do my float plus plus. That's just an easy way of saying whatever is inside of my float plus one more. And my int plus plus. And then at the end of it, we want to do console.writeLine. And then let's get my float first, and then my int afterwards. To autocomplete, whenever this box pops up, I just press tab. Let's build this. And then let's see what we get. So it's going to run for a few seconds while it counts up. And you'll see here that our float went up to something that ended in 6, while our int went up to something that ended in 8. Quite strange, one would say, but actually not. But it's because of this imprecision at higher numbers. So again, that is a thing you should be aware of, especially if you do what's called iterating. So, basically what I'm doing here on a float, you can basically get stuck. So be careful with floats. Floats are dangerous. Otherwise, they handle very much like the other numerics. You can add them, subtract them. We can divide, multiply, turn larger into smaller, and so on. We can also do it explicitly if we know they fit. So, we can take something like a float, my float, and then we know that This is a double, but we can convert it to a float because we know this is going to work and it's going to be fine. And we can write it out. And we'll see that we don't get any issues because we as the programmer knows that it's going to fit even though it's a double. Control Shift B. And let's run that. There we go. It works. So that was very short about floating point. We'll get to it again in the future, especially when we start comparing floating point numbers, which is a nightmare. I highly recommend reading this floating dash point dash guide. I'll probably put a link in the description. Let me actually just pull this aside so that I have it somewhere. There we go. And then I won't forget it, except I totally will. So let's look at the next one we have. Then we get a bool, which is a Boolean value. So Boolean, very fancy word for true or false. Now, if you come from a different language, such as C or C++, Booleans in C# are not treated as numbers. That's just, if you don't know what that means, just ignore it. It's just for the people that come here from a different language. All right. With that said, a Boolean, right? My bool can be either true, that is actually what you write, or false. What can we use this for? Whenever we need to check for some condition, a conditional statement, it evaluates to a bool in the end, one bool. And that bool will then either be true or false. And usually that is what you put inside something called an if statement. We will get more into what an if statement is later, but for now, just know that if the bool that is calculated. Ooh, please wait while we reconnect you. Am I disconnected from chat? Is everything just fucky-wucky? Am I just getting throttled hard? Am I dropping frames? Am I good? Are we good? Not dropping frames. I think it's just YouTube. Yeah, I'm pretty sure it's just YouTube. All right. So inside of our if, inside of the parentheses here, we can put a bool, something that evaluates, that's the word, evaluates to a bool in the end. So you can't just do like hello. That's not, because that doesn't evaluate to a bool, right? Cannot implicitly convert type string to bool. Makes sense. But what we can do is put my bool, for instance, and let's do console dot write line inside if, and then console dot write line outside if, to see what happens. So for now, my bool is false. Oh my lord. Please stop selecting this. There we go. No? It won't? Okay, whatever. I guess I get special cursor right now. So for now it's false. So let's see what happens when whatever is inside of the if evaluates to false. So I'll build, and we will run it. And you'll notice we only print the outside if. So we don't run the code inside the block here if this is false. What happens if it is true? Let's build it. then we run what is inside the block. And what you should very quickly be able to see here is that in the end, it always evaluates to one Boolean. So what I see a lot of beginners do is when they test for equality, they'll do something like myBool equals to true, which you don't need because this also gets calculated to something that is then finally output. So let's try and go a bit into comparison and conditionals. So we could have bool, myBool, and then we could have some calculation. For instance, is the number 1 smaller than 0? Right? You should know this symbol from math, smaller than. Let's try and console.writeLine myBool. So is 1 smaller than 0? I didn't build. There we go. False. So 1 is not smaller than 0. That makes sense to us. And we could then put this into an if, for instance, myBool console.writeLine inside if, right? Let's try something else. Is 1 bigger than 0? I build, we run it. True. And we go inside the if, because 1 is indeed bigger than 0. Then we could say, is 0 bigger than 0? We build, we run it. False, because 0 is not bigger than 0. Is 0 equal to 0? So that is 2 equal signs. Let's try and build that. Yes, it is. 0 is indeed equal to 0. Is 0 smaller than or equal to 0? We can also do that. Let's build it before I forget. True. 0 is smaller than or equal to 0. So let's try and see if -5 is smaller than or equal to 0. Yes, it is. All right. So that's some basic comparison operators. We could also start testing things like if hello is equal to hello. That it is. Now, we looked a bit about text before, so let's try some text here. So we have the string here, my string A, and I'll say hello in this one. And then I'll have my string B, and it will just say hell. And then we will say is my string A equals to my string B. I build. It is not. False. But then what happens if I say plus O? Make that an O, not a 0. There we go. Build. true, right? So what you will notice here is that it evaluates is the correct word. It evaluates the sides of the equality operator before it then does the equality, right? Much like if I wrote 10 times 2 plus 1, it would say 10 times 2 first, so 20 plus 1, so 21. We can also prove that to ourselves by just putting it in here real quick. I'm just going to put this through. Shoot. I'm clicking on the wrong buttons. Control Shift B. Back to the console. 21, right? Because multiplication comes before addition. And much like that, evaluating what's on either side of our Boolean operators here comes before or comes after the evaluation of what's on them. So this doesn't become, 1 equal to 21. It becomes 1 equal to the entirety of the left-hand side. So let's try that. And it says true, because 21 is indeed equal to 21. All right. That's just very short on bools. So let's look at how far we are. So we looked a bit about variables, looked a bit about assignment, the equals. We had some about conversion and casting, integrals, floating point, booleans, and now we are at value types and reference types. So let me just get rid of all of this. And then up here, I'm going to, so again, I just want to reiterate, in my basic series, I'm not going to teach best practices. So don't do this in production code. Do this when you play around with the language and try and learn what it does. So we will do static void add one int I, and then we will say I plus plus. And then we will have another one where we do static void add one ref int I plus plus. All right. So let's make some here. So let's make an int x, give it 0, int y, give it 0, and what you'll notice is that the basic types that we've been working with so far have all been what's called value types. What that means is when we looked at the memory, I'll go back to my pretty drawing here, it only looked at the value inside of this block of memory. So it looked at what was inside the block of memory. Each block of memory in your RAM has an address. So this block of RAM could have been called A1, for instance. Let's just say it's called A1. Doesn't really matter. So this block is called A1. That's its address. Well, the address of a block of memory is also a data type. In C#, it's called a reference. In something like C and C++, it's called a pointer. If you come from C or C++, you can think of a reference as a wrapped pointer, right? It's just a wrapper around a pointer. So let's look a bit. So let's, take a look at what that means. So here we have our value type, int x, 0, int y, 0. And here we have some methods, right? So let's say that do I even need the methods? I don't even need the methods. You know what? Let's ignore methods for now and just look at this. So if I say x plus plus means adding 1, we could also minus minus. Let's do that. We've done enough what's called incrementing. And then we say y equals x. So we assign x into y. And then we say y plus plus, right? So here, x becomes minus 1. Here, y becomes x becomes minus 1. So what happens here? Well, because it's a value type, we only inserted the value from x, not the address to where that value was stored. So when we add 1 here, y becomes 0, but x stays at minus 1. So let's see what this means. So console.writeLine x, which should print out minus 1, console.writeLine y. Whoops, I forgot to build. Maybe. There we go, minus 1 and 0. Now, what does he mean about reference to a place in memory? That's stupid, what he's saying. Right. So a variable, what it really is that we are telling the computer, give me a place in memory, and I want you to treat it as this type. And then the computer has the address to that place in memory and the value in that place in memory. And we can ask for the address or the value of that variable. So let's try again, except this time we say that we want a reference, so a ref int. So we want the address to an int in memory somewhere, and we want the reference to x. So give me the address of x. Now I say x minus minus. So that is the value in x. And here we then say y plus plus. So what happens here? Well, it takes the address that's inside and it says, okay, take me to where that address is and let me manipulate that value. So let me try and draw this. And first of all, let's print this out. So I'm just going to build. And you'll see that we get 0, 0. They are the same, even though we did not perform the same operations on them. But in reality, we did. And that's what I'm going to try and show here. So new, don't save. So we have, I'm just going to open a window real quick because it's getting warm. There we go. So we have a block of memory. This is our block of memory. And then we have another block of memory. So these are our two variables, x and y. So this is x, and this is y. We tell x to be treated as the type int. That tells the computer how to read it and how much space to make for it. And then we tell y to be treated as a reference to an int. So the address of some int somewhere in memory. Then we put 0 inside of here. And then we put the address to x inside of here. So whenever we do anything to y, it says follow that address, which would lead us up here, and do your manipulation on that. And that's really all there is to it. I'm sure you can find a million videos on pointers and how they work. It's basically the same principles all throughout. If we have what's called a reference type, so right now we were dealing with value types, but if we have a reference type, let's have a look at those real quick. So close this, close this, close that. And then we go to reference types. I don't want to look at char just yet. We'll get to it. We can see that we have the built-in reference types dynamic, object, and string. And string is text as we saw before. And you might be wondering, well, why is string an address? Why is it not the letters that I actually put in it? And that takes us back to what we just skipped in value types, the char. Well, it's because a string is a list of chars somewhere in memory. So let's look at how that works. So let's have some string. Let's call this one x. I'll put x in it. And then let's have some string y, and let's put x in it. And then let's do some manipulation to y. So I will do what's called concatenating. It's not the specific characters that is concatenation. I could have also done what I've been doing before, which is this. But instead of doing equals the variable plus, I even think it wants us to simplify it. Yeah, so it wants us to use the compound assignment, which is basically what this character does. You can do it for, all normal arithmetic operations. Right now we just want a plus. When you do plus on strings, it's called concatenation. So here we're basically saying take this string y, put at the end of y. And then let's try and print out what they say. So we have console.writeLine x, console.writeLine y. Build, and then it's saying it's a reference type. So what we should get is xy, xy, but let's see what we get. Right, so we get x, xy. And that's something you should be aware of with strings, is that it will say it's a reference type but for most intents and purposes, it will be treated like a value type, right? But the reason why it's listed as reference type is because it's a list of characters, and lists are a reference type. That's, you can just write it down, and if you get asked somewhere, you can just run that off, even if you don't understand it. We'll get to lists and what that means, and why lists are reference types. But that's why, okay? So it's because it's a list of chars, technically an array, um, but they are treated much like value types, right? So that's just something to look out for. And of course, the last one was char for our value types. Instead of doing I already forgot what they were called again. Wait, did I press insert? I did. Where's insert? There it is. Right. If you get that square, it's because you accidentally pressed insert. So just press insert again on your keyboard. Should be good. Right. Let me just look up what they were called again because I keep forgetting. English is hard, okay? Quotations. Right. So instead of quotations, we just do an apostrophe, which is just one long boy here. And then it's just one character, like A. That's it. That's a char. Congratulations, you now know what a char is. Let's hop back into our list here real quick. So we talked a bit about value types and reference types. We talked a little about strings. Now let's talk about object. So object is quite a big boy in C#. If we just click on system.object here, it even says here, if I go back real quick, all types, predefined and user-defined, reference types, and value types inherit directly or indirectly from system.object. So basically everything we work with in C# underneath the surface is an object. And we can assign any value of any type to any variables of type object because of that truth. So I could take my int of 5, and then I could take an object, call it my object, and then put my int into it. And then when we try and write it out, what do we get? We actually get 5, right? Quite interesting. Let's try and put a different value in there. Let's take a string. So I'm going to have the same variable here, but then we're going to make a string. My string. Hello. Take my object and put my string into it. Now what do we get? It actually prints out hello. So why don't we just use object for everything if it's so easy to work with? Well, because then you lose your type safety. Because I could say my object plus equals 1, and we get here plus equals cannot be applied to operands of type object and int. If I tried it with something like hello, whoops, whatever, I can't spell. we don't quite get the same issue. Um, but the type safety is there to also help us with which operations we can do on a type. Um, if I were to go back here, right? So now my object is an int, and then I say my object minus equals 1. I can't do that, I can't do any arithmetic on my object. So that's a bit of a poopy. And I would have to convert my object to whichever number I needed, number type, then do the arithmetic and then save it back or assign it back into my object afterwards. That would be super poopy. We don't want that. So we use the types where appropriate, and usually you will never see object used in real code. There we go. Let's look a bit at the last one, which is dynamic. So dynamic is what's called a dynamically typed type. Unlike object, which is still type strong, dynamic is not. So you saw how we couldn't do addition on an object? Well, you can do that on dynamic. You can do everything on dynamic, which is quite scary to a C# programmer. If you're used to something like JavaScript, this is basically how variables are treated in JavaScript. So let's try it. So we have dynamic, my dynamic, please. There we go, my dynamic. Let's put 1 in there. Let's try taking my dynamic plus equals to 5. We can do that. Let's take my dynamic plus equals 0.1. We can do that as well. Let's take my dynamic plus equals hello. We're also allowed to do that. Now what's going on here? Let's try and write this out and see what happens. So we get 6.1 hello. So what's happening here is much like what happens in JavaScript. So first it becomes an int, a 32-bit signed int. Then we add 5 to it, and 5 is an int, and dynamic is an int, so it treats these as an int addition. Then we try and add a double to it, so it says, well, here I have an int, I can convert that to a double, and this is a double, so I'm going to add them as if they were doubles. And then it goes, well, now I need to add a string to it. Well, I can convert 6.1 to a string, just a string that says 6.1, and then I'll add hello to it. So that's basically what's happening here. Dynamic is good for very few occasions. Like if you have something like a view bag, other types of bags, just generally bags and buckets when you need that, dynamic is okay. Otherwise, I would recommend you stay away from it. And the last one you saw I had on my list, but is not on the value of reference types, is void. So what is void? You've probably seen void. So we have void right here, for instance. What does that mean? Well, void means the absence of a type. So anywhere where the language requires you to define a type, such as here in our method, where we are supposed to say, when this method has run, what type does it evaluate to? We can use void to tell the compiler that there is no type. There is nothing that it evaluates to. It just runs. I don't even know if you can change it to an int, can you? No, you can't. All right. Or no, wait, you can? Cool. So let's just return 0. That means it ran goodly. And let's try and build this. And let's try and run it. And that went fine. Let's try and return 1. That means error. Built it. And it still runs fine, but if another process ran this, it would know an error happened. We can go back to void here. And now you'll notice that we can't return anymore because we are saying this method does not return a type. So that is what void means. It is the absence of a type. And that takes us through the basics of type and how to get set up. So now you're ready to play a bit. And then next time we will look at functions and control flow and start doing a bit of logic. So thanks for hanging out with me and good luck on your coding.